Look at 2015 number 1. So here we have the rate at which the rainwater flows into the drain pipe is modeled by this way. So R is how much rainwater is flowing in. And then cubic feet per hour. And then from 0 to 8, partially blocked and drain. Water to drain is at the rate of, right over here, cubic feet per hour, same unit, from 0 to 8. And there's initial condition, 30 cubic feet of water at time t is equal to 0. All right, how many cubic feet of water flow into the pipe? So then what we want to do is we want to evaluate from 0 through 8 of the rainwater that comes in. So I'm going to do R of t dt. So if I have to do that, and I'll be using the calculator here, I'll set the y sub 1 as R of t. So we're going to type in 20 sine of fraction t squared x squared over 35. And I need to make sure that we are in radian mode. So mode. All right. Now, since I'm typing in, why don't I just type in second one, d of t as well here. So negative 0.04 x cubed plus 0.4 x squared, all right, plus 0.96 x. Alrighty, so that's what we have here. All right, now first question can be answered by integrating y sub 1 from 0 through 8. So I'm gonna quit math integrate, which is number 9 from 0 through 8. Y sub 1 alpha trace y sub 1, okay, and then dx. So 76.570, okay, 76.570. That's what we need to answer for part A. Part B is the amount of water in the pipe increasing or decreasing. There are two factors to see if how much water we have, or whether the water is increasing or decreasing. That's R of t versus d of t. So we get R of t, but we are looking at when t is equal to 3. So we have R of 3 minus d of 3. That's basically what we're looking at. What is that equal to? Now, so to do that, I'm going to use the calculator one more time. R was the y sub 1. So in our case, I'm going to do y sub 1. Open parentheses 3. Minus y sub 2. 3. And I get to realize that negative 0.313-ish. So negative 0.314, I guess, which is negative. Therefore, we can say amount of water is decreasing at t equals 3. So that's basically what we can say, because this one is negative. Now let's look at part C here. Minimum. We're looking for minimum. That means we need to consider beginning and ending, and then any critical point. So to find the critical point, what I'm going to do is this. The rate of change is R of t minus d of t. So in other words, I'm just going to unhighlight that one, same as this one. Just thirdly, I'm just going to do y sub 1 minus y sub 2. All right, and then I'm going to set 0 through 8. Oops. Window is 0 through 8. And then zoom fit so that it changes the y values automatically given x being 0 through 8. All right, so there it goes. I have one point where they're passing through the x-axis. So I'm going to do second trace 0, which is number 2. That looks like around, this is 4, then this is a bit more than 3. So I'm going to set the left bound as a 3. You can type it in if you want to. Right bound, I'm just going to type in 4 because it looks like it is between 3 and 4. And I want you to guess, okay, 3.27-ish. All right, so I'm going to quit. And x should be equal to 3.2 something, okay. I'm going to store that as a alpha a. All right, so we get, I'm going to set up the table. T, and then that's amount. 0, 3.27, 1, and then 8. So we have 3 values here. When t was equal to 0, we realized that it was 30 cubic feet. So when t was equal to 0, we had 30. We need the other two. We need to calculate that. The way which we're going to calculate is amount should be equal to starting from 30 plus from 0 through t, and then r of x minus d of x dx. We can write it in this way because r of x minus d of x is the rate at which the amount of water is changing, coming in minus draining out. So then what I'm going to do is I'm gonna calculate 30 plus math interval, which is number 9, 0 through, first I'm going to go for a because that's how we stored it, and then y sub 3 because that's where we put y sub 1 minus y sub 2 from our previous calculation, and then x. Then we get 27.965. And then let's do the same thing with 8. That was 48.544. All right, so then the question here is part C, minimum. At time t, at what time t is the amount minimum, justify answer. The time t is equal to right over here, 3.271. That's when we have the minimum amount. Alrighty, let's look at part D. Part D is a pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe a given rate until the pipe begins to overflow, right? But do not solve the equation involving the one or more intervals. Okay, so that means what? Amount that which we can calculate is 30 plus, same thing as this one, from 0 through t of r of x minus d of x dx has to be equal to 50, right? So that's basically what we can write. All right, so with that one, we are done, and I'll see you later.